Hi everyone, welcome to the Continuing Education Center, sponsored by DigiKey. I'm your host, Chris Wiltz, Managing Editor for Design News, and just really quick with some housekeeping items. As a reminder to everyone, you're eligible to earn IEEE professional development hours by attending these courses and participating in the chat function. However, there's some important things you need to know about earning the hours. The most important ones are that you need to attend the courses live, you need to attend a minimum of 2 of them per semester, and you need to fill out a course evaluation form within 2 weeks of the end of the class. You also need to attend 4 out of 5 classes per course, and you need to participate in the chat function every day that you attend. For more information on that, you can click on the link at the top of any of the CEC pages that says, How do I earn IEEE professional development hours? And you can read more details there. And with that, I'd like to introduce you to this week's lecturer, Don Wilcher. Don is a passionate teacher of electronics and technology and has been an electrical engineer for 26 years with industrial experience. He's worked on industrial robotic systems, automotive electronic modules and systems, and embedded wireless controls for small consumer appliances. He's currently developing 21st century educational products focusing on the Internet of Things for makers, engineers, technicians, and educators. He's also a certified electronics technician with ETA International and a book author. This week's course is Getting Hands-On with Arduino Mechatronics, and it begins today with today's course introduction, Driving LCDs and Audio Alarms with an Arduino. As a reminder, everyone, if you haven't already, please download the PowerPoint from the classroom page. If you look above the live chat window, there's a heading that reads Special Educational Materials. If you right-click on the link for today's slide deck, save it to your desktop, then you can open it and follow along with Don. Don's PowerPoint will take about a half hour, and then he'll come into the live chat and answer your questions directly. And with that, Don, I'll hand it over to you.
All right. Thanks, Chris. And again, I want to welcome everyone to this week-long webinar series on getting hands-on with the Arduino Mechatronics. And today we're going to do an introduction about what Mechatronics is, and also we got some cool projects that I mapped out in terms of how to use an Arduino to operate an LCD, and also how to create little audible alarm with the Arduino. So with that, we're going to move on to slide number 2. So as you can see in today's agenda, we're going to have an introduction to what Mechatronics is, and also we're going to show some pretty nice projects in terms of what people are doing with Arduinos related to the Mechatronics. So there'll be some project examples, and then we'll kind of wrap up the course, which I call the Arduino's Mechatronics Hands-On Project. And I've got 2 projects that we're going to explore. And again, there's a parts list that's been posted within this series, and it has most of the components that you need to do the projects. And also I got some reference material related to 2 of my books where you can get additional information about additional Mechatronics projects you can do. So with that, we're going to move on to slide. So you can see here, this is a Wikipedia definition of what Mechatronics is, and it states basically it's an interdisciplinary field of engineering that integrates design techniques and precision, mechanical engineering, control theory, computer science, and electronics into the overall design process. So that's, kind of a very technical explanation of what Mechatronics is. But if you kind of pull out some key words there, one being mechanical, the other being electronics, and the last one, computer science. That's really what it's about. It's the integration of those 3 disciplines and how you can actually improve the overall efficiency and behavior of mechanical-based systems. So with that, we're going to move on to slide number 4. So you can see here, I've got this nice Mechatronics word cloud. And these are some of the things related to Mechatronics. You can see there's robotics, of course, Mechatronics, which is the integration of mechanical engineering, electronics engineering, and the computer science. And some folks actually are now including the IT, information technology, because as most of you are aware of, the Internet of Things is really taking root, and there's a lot of exciting development that's happening in that sphere related to data. Of course, we've got machine learning and the data sciences that support that machine learning discipline. So, again, you got control engineering, computer engineering. Also in the back, you see home automation. And one of the slides that I'm going to present related to an example of the Arduino, someone has actually took a basic humidifier and using Arduino with a relay and some simple sensors, they've created a automated humidifier. So again, you know, I always talk about with my students and again with you folks based on my previous design news webinars, you know, it's limited by your imagination. I mean, there's no constraint. It's just basically, you know, what you would like to put into your design. And with these very cost-effective tools, meaning one being the Arduino, there's a lot of cool things you can do with it. Just quickly, I want to point out some other areas that Mechatronics is really making an impact in. You know, Design News is actually covering some of these topics in their blogs. Like, for example, exoskeletons. That's becoming a hot topic related to helping paraplegic or quadriplegics to be able to move using mechanical systems and how computer technology is helping in that endeavor. I mentioned a little bit about machine learning. I'm actually exploring that topic, and it's pretty fascinating because, you know, you can take something as simple as a Excel spreadsheet and using linear regression, you can actually map out the trends, and when you add the algorithm portion, that's where the machine learning aspect comes into play. So there's a lot of cool things that's happening with that field as well. So with that, we're going to move on to slide number 5. So now that we have an understanding about Mechatronics and how it ties in with this new world that we're seeing in terms of mechanical-based systems, home automation, you know, the exoskeleton. Here's some examples of some Arduino Mechatronics projects that I found online, and there's abundance of them. So I mentioned about the Arduino humidifier, which we're going to talk about in depth in a few minutes here. But you can see on the right-hand side at the top, there's the Arduino motor shield. And, you know, I love Adafruit because, you know, she has a lot of cool tutorials and SparkFun as well. This motor shield, as you can see, it's got different, as I call it, motor genres. You got basically a DC motor, you got a little servo motor, and, of course, you got a stepper motor. And with that particular shield, you can do some fascinating projects in the world of robotics, okay? And we'll be talking about that, of course, as well. In the lower right, the lower left corner, you see an Arduino robot car. So, again, that ties in with that, you know, concept of taking mechanics and enhancing it with sensor technology. And, of course, you have, you know, the algorithms that allow the robot to do some sophisticated activities. And then the last picture you see there is basically a stepper motor controller. It's kind of like an offshoot of the motor shield that you see on the top right corner, where now it's more dedicated for, in this case, driving stepper motors. You can see the size of the stepper motors, more industrial strength. So, again, a lot of nice things you can do with the Arduino, and the electronics are relatively cheap. You can actually spin your own, or in this case, you can buy off-the-shelf electronic controllers, and with the software, you can make it do some really awesome things in terms of mechatronics applications. So with that, we're going to move on to slide number 6. So first question of today is Mechatronics improves mechanical systems by using software and optical components. And you can see the two selections. Either it's true or false. And again, you guys always do an awesome job in your response and engagement factor. So again, here's the first question for the kickoff of our Getting Hands-On with Arduino Mechatronics series. Okay, so I look forward to seeing what you guys come up with in terms of the answer. All right, with that, we're going to move on to slide number 7. So, as I mentioned earlier, this Arduino humidifier project, and it's a really fascinating project because the author actually goes into details about how he has created the code that will allow the Arduino to take an ordinary humidifier and give it some additional intelligence. And you can see on the right side of this slide here, it's got an earlier version of an Arduino, which, the Arduino, when Massimo Bassani, he's one of the co-founders of the Arduino company, he really put in a lot of thought into developing the Arduino, because even though this particular brand of Arduino is no longer offered, the software is universal for all the Arduino platforms. And that's really cool because, again, it's about open source, the community, and being able to share and exchange ideas. So if you have that version, which I do have that version there, or if you got the latest version, the Arduino Uno, or if you have the Mega 2560, which is basically, as I call it, an Arduino pumped up on steroids, it's got a lot of I/O and a lot of useful resources that you can use at your disposal based on the header connectors. Again, it's about the openness and the community. So you can see right next to the Arduino there is an encoder, and what that person has done is there's a little organic LED display, or OLED for short, and that's where you can actually set the set point for the humidifier to detect the right trigger point in terms of how that humidifier is going to respond based on the humidity sensor that's on the breadboard. And again, if you get a chance, I provided some additional project details. If you click on that link, it's a very nice article. As a matter of fact, I have it here in my office, and I was just going over it before the presentation. And it's got some really good information about how to write software for the Arduino. I like his method of how he took basically chunks, made it modular, and he explains how those little software functions work to create this basic humidifier using the Arduino. With that, we're going to move on to slide number 8. Here's another example of the Arduino being used in a Mechatronics project. It's the Parallax Arduino Bobot. You can see that. The abbreviation stands for Board of Education. There's a link there. And I actually use these in my college classes. I teach high school students. They are part of a dual enrollment program, so they can enroll into the electrical systems technology program at the local college where I teach, which is Bevel State. And we use these particular robots to talk about sensor development, algorithm development, how to wire up circuits using circuit schematic diagrams. So you can see here there's two little infrared sensors, and this will allow you to control your robot using a little infrared remote handheld unit, any type of handheld unit, because software is universal. And again, you can't see it, but underneath that shield, as they call it, that's the Arduino Bobot shield. There's the actual Arduino that resides underneath that board. So again, a lot of nice things you can do with the Arduino. This one has as you can see, it's got two wheels. There's a little caster, as I call it, little ball caster in front of the Bobot, and it allows it to navigate. So it's got, basically two control wheels on each side where the servo motors are, and then again it's got the caster, and you can actually make it do some awesome things. Like when I work with my students, they're actually playing around with whiskers and having it detect objects, and it will actually move backwards and reposition itself and go in a different direction. So again, I got the link there where you can explore it. I believe this particular kit costs maybe about say $150 to maybe $180. Not a bad investment if you got other. It comes with all the material that you need: the chassis, the wheels, the electronics, and it's a real nice way to get acclimated to the world of robotics using little gripper that you can use along with the robot where it can actually pick up objects as well. So, again, a lot of nice, cool things that you can do with this particular platform with the Arduino. So with that, we're going to move on to slide number 9. So here's question number 2. What type of display is used in the Arduino humidifier project? So you can see your 3 selections. You got A, LCD, B, LED, C, OLED, and D, none of the above. Okay, and we talked about that particular display unit in the previous slide. So again, I know you guys are going to hit the nail. I'm going to have to come up with some more trickier questions. But again, this is question number 2 for today's webinar. Okay, look forward to seeing your answers. So with that, we're going to move on to slide number 10. So this is what I call playing in the sandbox. I've mapped out some projects to kind of get you acclimated to if you have never used an Arduino, then these projects will allow you to get acclimated very quickly in what I call a user-friendly and fun manner. So the first project we're going to talk about is the Arduino and LCDs, and the project is what I call a do-it-yourself serial monitor marquee. And then the second project we're going to explore is the Arduino and how we can actually use the Arduino to provide audible alarms, in this case an audio alarm. The project that we're going to demonstrate how we can use the Arduino for an audible alarm is a metal checker. So again, I provided 2 books. As Chris mentioned, I'm a book author and I love to write and get my ideas on paper. So I have 2 books here that I've written. One is the Arduino Electronics Blueprint, and the next one there is Make Basic Arduino Project. So again, if you want additional information about these projects or other Mechatronic-based projects, these are 2 books that, well, of course, I'll recommend because I'm the author. But it's got some really good information in it that you can explore. Okay, so with that, I'm going to move on to slide number 11. So here's the first project, and it's entitled "How to Create a Serial Monitor Marquee." With a marquee, it displays messages, and the way it's set up is basically there's a software application that resides on your desktop or notebook computer, and what you can do with that software is you can actually type in a message, or depending on how the marquee is set up, you can type in simple phrases, and once you have that, it'll actually send that information to the marquee. So you can see in the top little concept drawing, as I call it, it shows a desktop, in this case a notebook computer, and it's got, of course, the infamous "Hello World" and the communication between serial monitor, marquee, and the notebook is, of course, the standard USB cable. You can see it's one direction. Traditionally, USB is bidirectional because you've got to transmit and receive, but in this case, we're not sending information back to the desktop or notebook computer, so that's why I'm showing the arrow being lateral. It's just one direction. Okay, and of course, once you type that in and hit the enter key, you'll see it on the LCD display, "Hello World." Okay, the bottom diagram is more of a kind of a functional block diagram, as I call it. You can see there, I got what the actual display or the unit that's going to actually allow you to enter the message is the desktop PC or notebook computer, and then of course it ties into the Arduino Uno, and then there's the LCD display, a 16 by 2 LCD, and we'll talk a little bit about LCDs in the next slides. But you notice I have a slash with a number, and that number relates to what I call the control or data line. So in this case, we're using one pin, and the pin that we're using is the receive pin of the Arduino, and then coming out of the Arduino, we have 6 control lines that will interface or wire to the LCD and then we'll be able to see the message based on what we type into the desktop PC or notebook computer. So again, I always like to do graphics. You know, they say pictures worth 1,000 words, and hopefully you folks can kind of see how it's laid out from the concept drawing to what I call the functional block diagram. Okay, so with that, we're going to move on to slide number 12. So, question number 3. What type of electronic component is used to control the OLED LCD glass? Now, I'm going to give you a clue because, again, I want to kind of challenge you guys. When you look at the selection of questions, if you have a background in electronics, then you probably already know what it is. But for the ones who are getting into the world of electronics based off of this webinar series, just think about you have this LCD, and in order for it to control the individual pixels of the LCD, which stands for liquid crystal display, it needs a little brain, okay? And that brain is going to have the right timing sequences, and also it will allow it to, again, take data lines from the Arduino and provide the right control signals, okay? So hopefully with that clue, you'll be able to figure out which component is used to control the OLED LCD glass, okay? Again, look forward to seeing what your responses are. We're going to be moving on to slide number 13. So here is the serial monitor marquee wiring diagram, and the software package that I use for creating this is called Fritzen. It's a free download, and with Fritzen software, you can create, of course, what they call the breadboard view, which you see in front of you on your screen. And then from there, you can actually create a circuit schematic diagram, which we're going to see in a few minutes. And then if you really are like, man, this is the coolest thing I ever made, I want to, show it to my family, friends, people in the makerspace, I want to make a nice little printed circuit board, it has that capability, too, where you can actually design a PCB. And all the tools work seamlessly together. It's not like some tools where you have to import, say, your Gerber files to do the manufacturing, or you have to import the actual, they call the net list that shows the geometry of how these devices are connected. It's all in one package, and Fritzen has done a superb job. They've always update the libraries. You'll see when you open up the Fritzen software that a little message will pop up and say, hey, here's the latest update, and it'll show you exactly what the update is in terms of components. So it's a nice little, as I call it, ECAD, electronic computer aided design package, and it's free. So again, I encourage all you folks that are online here to explore that, because if you're really into wanting to get into this maker movement, or you have an idea for a Kickstarter, this is a nice way to actually do your development. So you can see here it shows how the wiring of the LCD is connected to the Arduino, and it's very simple wiring. As a matter of fact, with technology, they've actually came up with a new version of LCD where now it's a serial-based LCD. So instead of having 6 control lines, you only have 2 control lines, and that's where you can actually send the data over, using a transmit-receive configuration. And now that will save resources on your Arduino. So instead of using 6 lines, you use 2, and then you have the remainder to use for other I/O-type activities for your project. So with that, we're going to be moving on to slide number 14. So here is the circuit schematic diagram, and again, this was created using the Fritzen software. One thing, just to kind of let you know how the Fritzen software works related to this circuit schematic diagram. Once you create your breadboard version, you'll click on the little schematic tab on the Fritzen software, and then you'll see all these components just kind of like randomly placed on the screen. The key behind that is you need to move them in an arrangement where you can actually see how the true wiring is going to be set up. So it takes a little patience. There is a little small learning curve, but as you practice with the software, you'll start to develop your own technique to rapidly develop your circuit schematic diagram. What I traditionally like to do when I create my circuit schematic diagrams, I always think of it in terms of a basic computer block diagram. We have your inputs on the left, you have your processor in the middle, and then you'll have your output devices on the right. So that's what I have arranged here. We don't have any input devices, so therefore you don't see anything on the right-hand side of that Arduino circuit block symbol, but you see that it's like in the center, if you will, and then, of course, you have your OLED, which is on the right-hand side. So, again, when I wire up my circuits, and I tell my students this, it's like reading left to right. So you start from the left side, and then you just wire the components, you do some testing, and then you move further into the project, and when it's completed, it'll minimize the errors, any troubleshooting, and also your project should work flawlessly if you follow that methodology. And you can see down here, this is the type of LCD that we're using. It's a monochrome LCD. I provided there's a parts list, and there's a link to DigiKey where you can actually order an LCD of this version. It's backlit. The way you can tell that it's backlit with an LED is if you look on the right-hand side, you'll see this little crystal glass-looking component. Well, that's the actual LED, and it's tied with the glass. So when you actually wired it up with the backlight pins, it'll actually give you a nice effect in terms of the display is now lit, and you have a nice visual-looking display. So, again, the parts list is included with the series here. If you have your own parts, that's great. If not, then that's another resource that you can use to build these projects. Okay? So with that, we're going to move on to slide number 15. Here's question number 4. How many wires are required for data control of a traditional LCD when used with an Arduino? Here's your selection. So we talked about that, talked about the new way of controlling LCDs, and I know you guys are going to get this question. Again, you got the circuit schematic diagram and the breadboard wiring diagram. It's going to give you the answer to this question. Okay, so we're going to move on to slide number 16. So once you have your project wired up, and if you found any wiring mistakes, they're corrected. The software to actually upload to the Arduino, it's already baked in to the Arduino's IDE, which is the Integrated Development Environment. So I provided a little graphics here that shows with all of the various versions of the Arduino IDE, it has the examples of code that you can use to get you to rapidly develop your projects or to get acclimated to, in this case, the Arduino. So you can see here to find the serial monitor or serial display software, it's the examples, and you'll get this window that's got a list of example code or sketches, as they call it. You go down to where it's got liquid crystal, and then from there you just find the serial display, and then you'll click on that, and then you'll see the actual code. I didn't provide the code here because, again, it's embedded within the IDE. And, again, nice thing about Arduino and how they write their code is everything is commented. You can kind of see how things are set up in some areas that you can explore. So what will happen is once you upload it, then you'll just type in the serial monitor. There's a little area where you can type a message. And when you type in the message, it will automatically refresh the LCD screen, and you'll see the message right there. And, again, they provide directions on how you can actually use the code within your application as well. Okay? So with that, we're going to move on to slide number 17. So the next project is a simple little what I call metal checker. And what it allows you to do is you can see the two test leads. You can actually attach devices across the two leads, and it's got a little piezo buzzer, and it'll actually tell you if you got good connection, meaning continuity, or not. And again, that came out of the Arduino projects book, as you can see right there. So we're going to move on to slide number 18 to see some further details about this particular project. So here is a little block diagram, and you can see the metal object. That's, of course, the thing that we want to check. It could be a piece of wire. It can actually be a resistor. It could be a inductor. Anything that has some metallic properties related to it, that's what we want to test. And then we have an electronic switch, and that ties into the Arduino, and then we have a piezo buzzer. Okay, so that's the basic block diagram for our little metal checker device. Now moving on to slide number 19. Here's our wiring diagram, and you can see how everything's laid out. The DUT stands for device under test. I got that mapped out, and you can actually see how, in this case, we're using an NPN transistor, and it's a 2N3904. There's the pinout of that transistor. You can see how it's placed on the breadboard, and along with the appropriate resistors. We're going to move on to slide number 20. Here's our circuit schematic diagram. Again, this diagram, along with the, as I call electrical wiring diagram, or breadboard diagram, created in Fritzen. Okay, so again, it's a free download. You just type in fritzen.org, and you'll see that'll be the top hit, and you can go to the download page and download it. So you can see here we're using the transistor, the 2N34, as a switch. So what happens is if we have continuity with the device that we're checking, that will basically bias the transistor via the 5-volt supply, and then we have a base resistor that will turn on the transistor. And in this case, this transistor is wired as a common collector or emitter follower. It will provide a signal, in this case, a ground path or low voltage for the piezo, because at D7, that's where we're providing the output signal. So if everything is good, we'll hear a tone coming out of our little piezo buzzer and let us know that that object is good. In case of wiring, it means it has good continuity. There's no break in the wire. Okay? So we're going to move on to slide number 20. So here's the code, and it's relatively simple. You can see here, I got a little description. It says it turns on and off a piezo buzzer at pin 7 when the metal is placed across the sense wires of the metal sensor circuit attached to pin 6. So here, I got everything labeled in terms of comment statements. The pins are defined. And you can do some experimentation on this, and I encourage you guys to do that. So I put the comment statements all along with, when you look at the examples that come with the Arduino IDE, everything's commented, so you folks can go ahead and have a good time doing hands-on exploration and self-discovery. Okay. So again, pretty short code, and again, when it's wired up correctly, you place the device you want to test between the two sense wires, and you hear this little buzzing sound coming out of the piezo buzzer. And again, that's one aspect of the Arduino Mechatronics, is for audible indication. Okay. Another term that we use for metal checker, which most visual multimeters have when you put it on the ohm meter setting, is a continuity tester. So again, we have another device where we can check the continuity, okay, making sure that the wire is not broken in any fashion. Okay? So last question for today is, the metal checker is analogous to what basic electrical tester? Okay, so there's your selections right there. Again, I know you guys will nail it. Awesome, awesome participants out there in the world of design news. So we're going to move on to, well, that's it, folks. We just had our introduction about Mechatronics, and we got some projects for you guys to try out at home. Again, there's a parts list that's presented, posted, and again, I encourage you guys to try your hand at the project, and if you do the projects, I'd love to hear what your results are in the chat room in tomorrow's day 2 session of the Getting Hands-On with the Arduino Mechatronics series. So with that, I'm going to turn over to Chris.
Hey, thanks again, Don. And yes, like Don just said, for all your listeners that still have a few burning questions, please don't go away yet because he's going to be coming into the live chat in a minute and he'll be taking questions directly. Also, for those of you on social media, we'd like to encourage you to use the hashtag DNCEC on Twitter to share and discuss what you learned in today's class. And as a reminder, don't forget you still need to fill out the course evaluation form within 2 weeks of this Friday. There's a link on all the classroom pages that will direct you to the form, and you only need to fill it out once for the entire week's lecture. I'm Chris Wiltz, and thank you again for joining today's course, and we hope you'll be joining us for the rest of the week as well. And now we'll go join everyone in the live chat. Thanks, everyone.